Chapter 1, Section 4 deals with functions and what happens to them. The biggest thing with these functions would be they're called parent functions. All the functions that we're going to deal with are things that you should know and recognize the general shape of them, and then be able to apply what transformations happen to that parent function. So our list of parent functions starts with f of x equals x. This function ends up being just a straight line. It has a coordinate 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, and so on and so forth. And so it will look like that. It's a linear function. The domain of this function would be all reals from a negative infinity to infinity. The range is also going to be all reals. And because you have 1, 1, and a negative 1, negative 1, and also 2, 2, negative 2, negative 2, and 3, 3, negative 3, negative 3, this is an odd function. Because you can spin it about the origin, or for every x, y, there's a negative x, negative y. Our second function that you should recognize would be the absolute value function. In the absolute value function, you have a coordinate 0, 0. There's also 1, 1, and 2, 2, and 3, 3, and 4, 4, and 5, 5, and so on and so forth. So it does that, very similar to the linear function. It also has then negative 1, 1, negative 2, 2, negative 3, 3, and so on and so forth. And so it looks like that. In this case, again, the domain is going to be all reals. But the range is slightly different in that it's going to be all greater than or equal to 0. And this function, because you have 1, 1 and a negative 1, 1, and they're on opposite sides of the y-axis, this would be considered an even function. Our next two parent functions would be x squared, and x squared has 0, 0 as a coordinate, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. And so on and so forth. It is a parabola in shape, and the domain for it is still all reals, and the range would be just like the absolute value. It's all greater than or equal to 0. And just like absolute value, you can fold it along the y-axis, so it is an even function. Next we move on to x cubed, which still contains 0, 0. It has 1, 1, 2, 8, 3, 27, negative 1, negative 1, negative 2, negative 8, negative 3, negative 27, and so on and so forth. And so it looks like this. Domain, all reals. Range, same thing. And because each x, y has a negative x, negative y has another coordinate on this graph, it would be considered an odd function. Finally, we come to the square root of x. Square root of x still has 0, 0, and 1, 1. Then the next coordinate out would be 4, 2, 9, 3, 16, 4, 25, 5, and so on and so forth. And you cannot use a negative underneath the square root, so therefore our graph is going to look like this. Now, for the first time today, our domain is not all reals. It is going to be all greater than or equal to 0. And the range will be the same thing. And seeing as there's no coordinates on this side of our graph, it is neither odd nor even. The cubed root of x still has 0, 0 as a coordinate. 1, 1, 8, 2, 27, 3, 64, 4, and so on and so forth. That way, it would also have negative 1, negative 1, negative 8, negative 2, and so our graph goes like so. Domain, all reals. Range, same thing. Then we will move on to y f of x equals 1 over x. This one, for the first time today, does not have a coordinate at 0, 0 because you cannot divide by 0. So if you substitute a 1 in, you will get 1. So it has 1, 1. Substituting a 2 in will get you a half. A 3 in will get you a third. A 4 in gets you a fourth, and so on and so forth. That way, if you put a half in, 1 divided by a half is 2. And if you put a third in, you'll get 3. A fourth in, you'll get 4, and so on. So it looks like this on this part. And we'll run along the x-axis, and here we'll run along the y-axis. Now you can also substitute a negative 1 in, and you'll get a negative 1. A negative 2 will get you a negative 1/2. A negative 3 will get you a negative 1/3. And a negative 1/2 will get you a negative 2. A negative 1/3 will get you a negative 3. And so then this part will curve this way. Now the domain for this would be all reals except for 0. So all reals not equal to 0. The range will be the same thing. And because every x has a xy has a negative x, negative y, this function is odd. Moving on to 1 over x squared. Again, you cannot divide by 0. We will still have the coordinate 1, 1. If you substitute a 2 in, you will get a fourth. If you substitute a 3 in, you'll get a ninth. If you substitute a half in, you'll get 4. And if you substitute a third in, you'll get 9. So our graph will look like so. And then if you substitute a negative 1 in, you will get a positive 1. If you substitute a negative 2 in, you'll get a negative, or you'll get a positive 1/4. If you substitute a 3 in, it's 1/3 or 1/9. If you put a half in, it's going to be 4. And then this part of the graph will look like this. Domain is going to be just like this one. All reals not equal to 0. Now our range is not going to be all reals not equal to 0 because we have no negative values. So here we are going to be all reals greater than 0. And because every xy has a negative x, positive y, it is an even function. Because you can fold it along the y-axis. Then a new function that you saw a little bit of in yesterday's in section 1.3 is this function. In your book it is written this way. It's 2 lines. It looks like a bracket with 1 line in it. In some other books you will see it as just 2 lines next to the x. Or you may also see it as a line looks like that. This function is called the greatest integer function. The greatest integer function means it's the largest integer that is less than or equal to the value. So for example, if you have the greatest integer of 2, that answer would be 2. If you have the greatest integer of 2.3, that is still going to be 2. If you have the greatest integer of 2.67, that equals 2. If you have 2.999, the greatest integer that is less than or equal to 2.99 is still 2. Once you get to 3.01 or even 3, then the greatest integer becomes 3. So it's basically rounding down. Some books will also call it the floor function. Now, in your calculator, there is this, you can enter this as a function just like you can enter any of the other ones. And remember, with absolute value, you have to use ABS and find that in your calculator. TI people, you're in one place. Casio, you're in another. Well, with TI people, in math, under num, look for the int with the parentheses around it. For Casio, when you go in to enter a function, you need to push the OPTN button and then find num. And you have two choices. One is int and the other one is intg. intg is the correct one. Now, the look of the greatest integer function then will be, if you put a 0 in, you'd get 0. And anything from 0 to 1, you're still going to get 0. Then when it gets to 1, it's going to jump up to here. And then from 1 to 1.999 forever, you're going to get 1. And then once you get to 2, it's going to jump up again. And then it's going to draw all the way over to just before 3. And then it's going to go up again, and so on and so forth. Same on this side. And so it looks like that. The domain for this function is going to be all reals. Now the range is a little bit different. It doesn't include all real numbers because you can only get 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So our range is going to be just integers. And this function is neither, because you cannot spin it and get the same thing. And you can't fold it along the x-axis. Okay, these are the parent functions. If you know and recognize these in some equation, you should get the general shape of what the function is going to look like, no matter which one you're given. If you just see an x, you know you're going to have a line. If you see the absolute value, it's going to be a v of some sort. If it's x squared and an x in it, then you're going to have a parabola, or if it's even just x squared. If it's x cubed, you're going to have a wave. It could change some depending on what else is with it. Square root is that. Cubed root is something where it's a sideways wave. Something 1 over x goes in the first and fourth quadrant, although if it's different with something added to it, is not necessarily that. But it does have this shape. 1 over x squared looks like that. And our greatest integer function looks like steps. Now on your calculator, when you do graph the greatest integer function, depending on your calculator and the settings you have, there may be these lines going like so. They are not part of the function. It's just that your calculator has to draw one continuous flowing thing, and so it needs to draw this vertical line. It's not part of it. So now, once you know all of the parent functions, you will get things like this. If f of x is the absolute value of x, evaluate or find the function that is f of x minus 3. And if you recall from last year when we did these things in advanced algebra, when you have an x minus 3 and it's in the parentheses like this, this is going to shift our graph right 3 places. Because when it's with the x, it's the opposite. Now, if we were substituting x minus 3 into the function, it would become the absolute value of x minus 3. And so then our graph would be instead of at 0, 0, it would be at 3, 0. And it would still be from there up 1 and over 1, up 2 and over 2, up 3 and over 3, up 1 left 1, up 2 left 2, up 3 left 3. Domain would still be all reals. Range would be all greater than 0 and equal to 0. Doesn't matter what the function is, it's going to shift it to the right 3 if you're evaluating. If we were dealing with x squared, it would be the same thing, except now it would be a parabola. And then all of the rules would apply for that. Now the one thing that doesn't apply would be if it's even or odd. This function, because it's no longer along the y-axis, you cannot fold it on the y-axis to make it even, and you can't spin it at the origin, so it's not odd. So this child function would be considered neither, but the parent is even. Similarly, if you have something like f of x plus 2, if you were to write that as a function, it would be the absolute value of x plus 2. Now, since it is not with the x, remember, it goes in the same direction, so this would shift it up 2 places. And so our graph would be just up 2. Instead of 0, 0 would be 0, 2, and we would still have our v. And it would be up 1 over 1, up 2 over 2, up 1, left 1, up 2, left 2. Now this one would be considered an even function. Domain would be all reals. Range would be all greater than or equal to 2. And finally, if you had something where it was multiplied, 3 times f of x, since it is not with the x, this is going to stretch it vertically by a factor of 3. So if we were dealing with the absolute value of x, our graph would have a coordinate of 0, 0, and then usually it's over 1, up 1, but now because we have to be stretched vertically by 3, it would be over 1 and up 3. Usually it's over 2 and up 2, but now it's over 2 and up 6, because you have to multiply the y value by 3. Over 3, up 3 would become over 3 and up 9. And so it would just change the steepness. Same domain, same range, it would still be even. And with a function like this, because it's with the x, this is going to be dividing by the x values by 2. So it's going to compress your graph. So typically, if you have absolute value, it's over 1, up 1. Now it would be over half, up 1. It would be over 2, up 2, but now it would be over 1, up 2. Kind of has the same effect when you're dealing with absolute value. But know that when it's with the x, it's the opposite thing that happens, dividing the x values by 2, or whatever number. And when it's not with the x, if it's outside of the function, it is going to be the same thing with the y values. And this is everything that you should remember and recall. Most of this from last year. Now you're just going to apply it to all of these different functions that are called parent functions. And these are their siblings. Or not their sibling, their offspring. That would be a better word. All right, we'll see you on Monday.